Hello, this is the Ashrae Isbd competition Senior Design Showcase video, and we are the green team of UCF. My name is Arthur Applegate, and for this project, I acted as the head of communications and project development.
Hi, I'm Mohamed, and I'm head of implementation of Ashrae standards.
I'm Reece Simon, and I'm the head of technical work in Autodesk Revit.
I'm Wright. I'm head of technical work in Isbd and energy modeling.
I'm Yovino. I'm head of construction and equipment scheduling.
And for this project, our advisor was Nathaniel Boyd, and he acted as our stakeholder for this project.
To begin with the project goals and objectives, we have been approached to design a performing arts center at Sydney, Australia. This includes the building's mechanical systems. The areas of focus include the building's life cycle cost analysis, the building's low environmental impact, ensuring the comfort and health of all occupants, and having a creative, high-performance green design. To do this, we schematically design an energy-efficient, sustainable project approaching a net zero energy building with minimized demands for HVAC and all technical systems. Energy demand should be met with locally available or building-installed renewable energy sources. The building must be compliant with Ashrae Standard 189.1, the design for green buildings. The main objective for this project is for students like us to learn an integrated, sustainable building design process. That's all.
Moving forward, we needed to identify our project's impact on relevant stakeholders. We identified 3 stakeholders for our project: the environment, the owner of the building, and the students/performance hall patrons that will be occupying the building. Our project supports the investment of renewable and alternative construction and MEP systems in commercial and industrial applications. The elimination of pollutants from power generation reduces the negative environmental impacts. This is what we aim to do in net zero energy and net zero carbon emissions. The owner project requirements called for implementation of architectural and HVAC techniques that would lead to this net zero or net carbon building. We did this by adhering to Ashrae standards 90.1 and 189.1, moving forward with scheduling to make sure that we were accurately and reliably cooling and heating the building to its standards and set points. Lastly, the students and performance hall patrons that would be occupying the building need to be satisfied in terms of air conditioning, cooking, making sure there's no toxic fumes within the building. So what we did was we just made sure our occupants would enjoy a dynamic and comfortable atmosphere with ease of access. We made sure cooking and mechanical zones provide patrons with excellent food service and air conditioning. These were the project stakeholders and the impacts that they had.
Moving on, I'm going to be discussing the entire different project test plan stages and how we implemented feedback from our advisor. We began by designating specific roles and dividing up the workload throughout the entire project. So that way it would allow us to really collaborate creatively by allowing some of us to become specialists, more experts on different areas. So that way we were more in the know on that side of the project, and we could really communicate well with different forms of communication, such as GroupMe, Discord, email, Zoom, etc. Once we understood the project a little bit, we were able to create a timeline and do a bunch of background research on different systems for system selection. And past that, we had to implement a big box model where we got to test the 2 softwares we were using, Autodesk Revit and Isbd, one for more architectural layout and one for the energy modeling. And once we really understood all of it, we got to move on to the 90.1 Ashrae supplied building layout, which we put into Revit, put into Isbd. So we got all of the models, all of the reports that we needed. And once we showed it all to our advisor, he gave us a bunch of useful feedback that we were able to implement into our creation of the 189.1 standard version of the building, such as better ductwork layout, better zoning, better equipment selection, many different factors which improved the overall quality of the building. And once we replicated all the work with our advisor's advice for the 189.1, we were able to move forward with equipment selection for VAV boxes, air handling units, etc., as well as selecting solar panels to help reach that net zero for our energy. And once we had all that, we can move forward to the life cycle cost analysis, which allowed us to really show how good it is to have efficient equipment and mechanical designs in order to help with the long-term investment of a building of this size.
So, as was stated, Revit is the architectural program we used for the alternate design based on Ashrae Standard 189.1. If you look on your screen, this is a picture of the bottom floor of our proposed design, complete with architectural layouts, including mechanical rooms, a parking area, classrooms, music rooms, stairs, and our theater area. It also features the ductwork for our HVAC system, as well as our VAV boxes for thermal zones and our 2 air handling units for the floor. The basic way that we went through designing our alternate design was we started off with mapping out the overall area that would be designated to each floor according to our owner's requirements. And then from there, we designed the layout of each individual room. And then after that, doors, floors, stairs, and ceilings were created to fully put together our physical building. Once this was laid out, our HVAC system and related ductwork was implemented into the design. If you go to the next slide, what is shown below is a 3D rendering of our entire building featuring all 3 main floors. As you can see, this building is elongated overall with the goal of lowering solar heat gain. It is elongated and placed on our site in such a way that as the sun moves from the east to the west throughout the day, there's minimal surface area exposed to direct sunlight. What this does is it reduces how much solar heat goes into the building and allows our HVAC system not to have as much energy put into it to cool to the levels that we are required to reach. On the next slide, what you'll see is a 3D rendering of our mechanical room at the bottom level of our building. It includes an air handling unit, multiple VAVs, and ductwork that connects these to the supply and return air diffusers. A major challenge when we were designing the ductwork within Revit for our project was figuring out the spacing of the area designated for the ductwork. We had ensured that all the ducts would not cross through one another and that the layout was logical and fully connected. There was a lot of collaboration between us teammates to ensure that our ductwork was uniform and in design and in elevation.
To move our model from Revit to the energy simulation program, a secondary program called SketchUp was used. This program was chosen due to difficulties in modeling through Isbd. This allowed for easier room creation by allowing direct AutoCAD DFX import, which allows us to draw over the floor plan using the built-in line and rectangular tools. Another benefit to this program is it was built in for Isbd, so exporting was a breeze and there were no incompatibility errors. Here's a 3D layout for simulation program in Isbd. Each room is separated into different thermal templates, such as kitchen, office, corridors, restrooms, and theater. These templates dictate the room's internal gains, such as lighting equipment, its cooling and heating set points, and required airflow. These templates allow us to generate a simulation report that it takes the specific data set we need for the equipment selection, such as VAV boxes and air handling units. On the next slide, we see our energy report. This energy report laid out how much CFM, cubic feet per minute, each room needs and its cooling and heating loads. We were then able to calculate the loads for VAV boxes, air handling units, boilers, chillers, pumps from this data so that we can make our equipment schedules for equipment selection.
For closing thoughts, what motivated us to stay focused and see our project through to completion despite the challenges posed by COVID and social distancing? One of them was learning the integrated sustainable building design process and wanted to actually learn about this process so that we may do so and have experience for future work in industry, as well as earning an A in the course. At the beginning of this project, all team members agreed that this was a common goal that we had in mind. To overcome these challenges, one of the main things we did was to increase team bonding. We did this by meeting in person for team building and going to a local restaurant called Bar Louie. One of the biggest lessons that we learned throughout this project process that we will all apply to our future work in industry is the ability to collaborate on a long-term, real-life engineering problem with other people. This includes the ability to break down such a large and complicated tasks into smaller roles and then delegate them to team members. Another essential portion that we can use in industry is learning simulation and modeling software such as Isbd and Autodesk Revit. These will be invaluable, especially if team members go into the HVAC field. Our motivation behind choosing this topic and focusing on this particular problem was to gain experience on a broad range of mechanical engineering topics. This ranges from thermal modeling to fluid dynamics and even to the business side of engineering with life cycle cost analysis. Thank you.
Thank you.